So, hello guys, myself Borisina Mahabatro. I am a student from Kochbiar Government Engineering College and currently I am studying in Electronics and Communication Engineering Department. Today, I'm gonna explain the topic analog communication multiplexing. So, today we're gonna see that how the multiplexing works, what is multiplexing, and the different variation of multiplexing, and also demultiplexing. So here are the contents of today's explanation. Multiplexing overview, where we can see history of telephony and function of multiplexing and demultiplexing. After that, we are going to discuss on types of multiplexers, where analog multiplexers, digital multiplexers, and we can make the comparison of their types. After that, we're going to explain analog multiplexing, where we can see FDM, WDM applications of them, and digital multiplexing, where we can see TDM and synchronous and asynchronous TDM. After that, we can see here it is demultiplexing, and inside the section there are connections to destination and role in communication systems, and at last the conclusions. So at first we gonna jump to the topic multiplexing overview. So what is multiplexing? Multiplexing is the process of combining multiple signals into one signal over a shared medium. So when we have to combine multiple signals into one signal, it is called multiplexing. If the analog signals are multiplexed, then it is called analog multiplexing. Similarly, if the digital signals are multiplexed, it is called digital multiplexing. At the next point, multiplexing was first developed in telephony. Telephony is a company. It is based on telephone communication. We all know that. So multiplexing was first developed in that company. A number of signals were combined to send through a single cable. The process of multiplexing divides a communication channel into several number of logical channels, allotting each one for a different message signal or a data stream to be transferred. The device that does multiplexing can called as multiplexer or MUX. We can term the short name as MUX or MUX. As similar the reverse process, it is called demultiplexing, where extracting the number of channels from one which is done at the receiver is called as demultiplexing. The device that does demultiplexing can be called as demultiplexer or DMUX. So here is a illustration based on multiplexing and demultiplexing, where you can see their number of signals 1, 2, 3, and to the n. It is a multiplexer device. The multiplexer device multiplexing the number of channels into one channel, and here at the receiver device it is demultiplexer, which receives a single signal and then demultiplex the signal into several number of channels. In the next slide, we can see the history in telephony. So multiplexing was first developed for telephony. We have read it earlier, allowing multiple voices calls to be transmitted over a single cable. These innovations significantly improved communication efficiency and paved the way for modern telecommunication system. Yes, so here a picture you can see it is a old generation telephone company, and the multiplexing systems in the telephone company, it is it is significantly improved communication efficiency, and you can see many channels from one country come to the multiplexer device, and then with a single channel it is transferred to the other country, where a demultiplexing device receives the channel and then demultiplex to all the channels to various parts of the country. In the next slides, we can see function of multiplexer and demultiplexer. So a multiplexer combines several input signals into one output signal, while a demultiplexer reverses this process by distributing a single input signal into multiple outputs. Together they facilitate efficient data transmission. We have read it earlier. So now I'm gonna jump to the next slide. So our next topic is types of multiplexers. There are mainly two types of multiplexers, analog and digital. They are further divided into frequency division multiplexers or FDM, wavelength division multiplexing or WDM, and time division multiplexing or TDM. So here a table multiplexers, it is divided into two parts, analog and digital. Analog multiplexing is divided in two parts, frequency division multiplexing FDM or wavelength division multiplexing WDM, and digital multiplexing is in the part time division multiplexing TDM, and which is divided into two parts, synchronous TDM and asynchronous TDM. So now we're gonna see what is analog multiplexing and what is digital multiplexing. So in analog multiplexing combine analog signals based on their frequency or wavelength. So where the term frequency, wavelength, this comes, we have to understand that this is analog. So analog signals based on their frequency and wavelength, where the signals combine, it is analog multiplexing. They play a crucial role in traditional broadcasting or communication system, our communication system, telephone or TV. Uh, Here the analog multiplexers work, allowing multiple channels to operate simultaneously without interference. Now in digital multiplexing, so digital multiplexers handle discrete bits of information. So where it is digital, there is a discrete signal, either it's 0 or 1 or discrete any numbers or any information, it is digital. So digital multiplexers handle discrete bits of information, organizing data into frames or packets. They're essential in digital communication where multiple data streams share the same transmission medium, maximizing bandwidth efficiency. In the next slide, we have comparison of types where we have to compare the analog multiplexing and digital multiplexing. So analog multiplexing focuses on waveforms and frequencies, while digital multiplexing deals with discrete data. Understanding these distinctions allows for the selection of appropriate multiplexing techniques based on communication needs. In the next slides, we have analog multiplexing. We are discussing uh, widely the analog multiplexing, and analog multiplexing is what the signals used in analog multiplexing techniques are analog in nature. The analog signals are multiplexed according to the frequency or wavelength. So there are two types of analog multiplexing. First we have frequency division multiplexing, FDM. So what is FDM? FDM is an analog multiplexing technique that divides the available bandwidth of a communication medium into separate frequency bands, each carrying a different signal. So where we have separate frequency bands where the communication medium or a communication bandwidth we can that is available into separate frequency bands, we can say that it is FDM or frequency division multiplexing. It allows multiple signals to be transmitted simultaneously over a single medium by allocating a unique frequency for each signal, similar to how different radio station broadcast at varying frequency. So there is use of FDM. We can see in our real life a traditional television transmitter or which sends a number of channels through a single cable use FDM. So in our TV we can see that a single channel comes to a TV, and from that channel we receive the signals for different types of channels, or we have different type of channel which comes under that single cable. So we use FDM in that case. Next we have wavelength division multiplexing or WDM. Wavelength division multiplexing is an analog technique, obviously, in which many data streams of different wavelengths are transmitted in light spectrum. So in analog division multiplexing, in frequency division multiplexing, you can see that the data streams or the different channels come under a cable. In the wavelength division multiplexing, we can see that the data streams of different wavelengths are transmitted in light spectrum. If the wavelength increases, the frequency of the signal decreases. A prism which can turn different wavelength into a single line can be used at the output of multiplexers and input of demultiplexers. So the example is optical fiber communication use WDM technique to merge different wavelength into a single light for communication. So optical fiber is the greatest example of wavelength division multiplexing. So in our house we all use GeoFiber, GeoNet, and there the optical fiber are used where WDM is used. Next we have applications of analog multiplexing. Analog multiplexing, we have various applications. We have seen earlier that TV and optical fiber use analog multiplexing. So there are some more points: television broadcasting, and other example, radio communication, traditional telephone system. Multiple calls can be handled through simultaneously through multiplexing techniques, enhancing the efficiency of voice and data transmission. Next we have the point digital multiplexing. The term digital represents the discrete bits of information. We have discussed it earlier. Hence, the available data is in the form of frames or packets, which are discrete. In the digital type, we have time division multiplexing or TDM. TDM is a digital multiplexing method that segregates time into discrete slots. So in digital division multiplexing, we have time and we segregate it into different slots, allowing multiple signals to share the same transmission medium by allocating different types slots to each signal. This technique ensures that only one signal is transmitted at any given instant, improving data management and reducing changes of interference. In that TDM, we have two types. Firstly, the synchronous TDM. In synchronous TDM, the input is connected to a frame. If there are n numbers of connections, then the frame is divided into n time slots. One slot is allocated for each input line. In the technique, the sampling rate is common for all signals and hence the same clock input is given. The multiplexing allocates the same slot to each device at all times. Second, we have asynchronous TDM. In asynchronous TDM, the sampling rate is different for each of the signals and a common clock is not required. If the allotted device for a time slot transmits nothing and sits idle, then the slot can be allotted to another device, unlike synchronous. So it is you can say it is a betterment of asynchronous TDM. This type of TDM is used in asynchronous transfer mode networks. And lastly, we have the topic demultiplexing, where we can discuss that how we're going to receive the signal and then turn it into many channels or many signals. Demultiplexers are used to connect a single source of multiple destinations. So a single source to multiple destinations, as we have discussed earlier. This process is the reverse process of multiplexing. As mentioned previously, it is used mostly at the receivers. Demultiplexing has many applications. It is used in receivers in the communication system. It is used in arithmetic and logical unit in computers to supply power and to pass on communication. Demultiplexers are used as serial to parallel converters. The serial data is given as input to demultiplexers at regular interval and a counter is attached to it to control the output of the demultiplexer. Both the multiplexer and demultiplexer plays an important role in communication system, both at the transmitter and the receiver section. So here we can see the topic connection to destinations. Demultiplexers are fundamental in routing a single source signal to multiple output destinations. For instance, they connect a single communication line like a fiber optic cable to multiple devices or endpoints, allowing diverse data streams to reach their intended recipient efficiently. As we have discussed earlier, that as the in the demultiplexing sections, a single channel comes as the to the receiving point, and then the demultiplexer makes it to various channels or various endpoints and distribute it to the various zones, which is very much important to telecommunication system. And now the role in communication system of demultiplexers. Demultiplexing plays a crucial role in advanced communication systems by ensuring the signals are accurately directed to their respective channels. It complements multiplexing by allowing the system to efficiently unpack and allocate transmitted data streams, thereby enhancing overall network performance and communication integrity. And at last, we have come to the conclusions of our presentation. Multiplexing and demultiplexing are essential techniques in modern communication system, allowing for efficient use of bandwidth and effective data management. Understanding their processes and applications is crucial for advancing telecommunications and enhancing connectivity in various industries. So thank you guys to read to see our presentation, and thank you to everyone.